smell that?
I do smell that way. I smell apples and pears.
Oh wow, I smell something different. I smell wintergreen.
Oh yes.
The evergreen plant of North America.
I know it well, It smells lovely, as do esters sometimes.
Yes, esters sometimes smell, so that's very coincidental that they're in the corner.
That is. I think that would be esters, Wayne.
Exactly. Well done, whoever did that.
Well done them. Well, what predicament, Wayne?
What's that?
I don't know everything.
I've got a predicament.
Yeah.
I don't know everything.
This is an issue. Alright, what do you know? Just tell me all of it.
The esters I'm really good at is and the fruits.
Yeah, it's good to condense everything you know into just esters. That was a good move. Well done. I was going to tell you everything. Okay, things I know are and the goats, which is
so we can teach each other everything.
Yeah,
by the end, me, you, all the millions of viewers, and Miss Martin will be pros.
Now we're so ready for their exams. So millions, are you ready?
You ready?
Are you ready?
I think you should go first because what you know is the building blocks.
I think it is.
So I'm going to go over here and learn.
Alright, come on, part of the audience. He's merged here, it's beautiful. He's actually grown a camera out of his head, just like a Dalek. So, what we have, a question I will hear you screaming. I've got an idea, Wayne.
Okay.
You can tell me all their questions.
Okay. So I'm hearing, why do you have long hair?
Not a bit to say.
Okay, I'm also hearing,
Yeah.
get on with the ester thing.
Oh, sorry, okay. So how do you form an ester? Good question, good question. Well done, guys. Congratulations. So you need a carboxylic acid and an alcohol.
Okay.
So, would you like to name someone?
Absolutely. Thank you. So I'm hearing Jim. Well done, Jim.
Alright, Jim.
So I'm hearing
It was like art attack. It's art that Jim has made. It's lovely art, Jim.
And here's one I made earlier.
Alright. That's a Saturday kitchen.
And these are all just hydrogens. We're not going to make anything jazzy on there, just hydrogens.
Oh, okay. So, those are our reactions. I'm going to name them. That's a good start, I think.
Absolutely.
So, I'm going to name that one Jim, because Jimmy gave it to me. No, I'm going to call it methanoic acid, because that's what it is, and this one's propanol. But I'm just going to call it meth and prop.
Meth and prop. We love meth and prop in the studio here.
We do. They're our favourite things.
Don't do drugs, kids.
Don't do drugs, but using meth as a prop, that's fine.
That's fine.
That's fine.
So, I've got this carboxylic and the alcohol, but now, what?
Well, they react through a condensation reaction.
Oh, I know what that means.
Yeah.
That means you remove water.
You do. So water is at the end, but for water to be formed, you need to have removed 2 hydrogens and 1 oxygen. So where are they coming from?
Well, there's 2 oxygens here, and there's an oxygen here, yeah?
2 hydrogens, yeah, go on.
2 hydrogens here, and an
Yeah.
oxygen here.
There is.
That's water.
It's not that. How about another guess one?
OH there,
Right.
H there, that's water.
No.
Oh, I'm out.
Sorry, there's 1 left. And it's the OH here, and the H here. This is always the way around. It's always the OH from the carboxylic acid and the H from the alcohol.
Okay.
So that's formed, and then these two, like bond together, like a beautiful connection forming an ester, but not by themselves.
Oh, they need a catalyst,
They need
right?
a catalyst, yeah.
So, iron?
No.
Nickel?
No.
Oh, it's got to be an acid then.
It is an acid. You got any suggestions?
Hydrochloric,
No.
nitric, ethanoic,
No.
sulfuric.
Yes.
Got
there in
diluted?
the end.
Diluted?
No.
Concentrated?
Concentrated.
Right, got it in the end.
Right, got it in the end. So we have concentrated H2SO4. I want to call it H2SO4 Kong. Original, I know. It was good. So these two
that's our catalyst.
bond together, and they go around this oxygen. So I'm going to draw this chain first. So we have our 3 C's.
They are unchanged, but then this O is needing a bond, and coincidentally, this C is needed a bond, so that's what it bonds to. And that is the result what Triv has drawn up there. That is an ester.
That is an ester, but we need to name the ester.
Okay, I'm gonna take a shot in the dark.
A shot in the dark?
Yeah, I'm gonna.
Right. So for dark you need it.
Took a shot, missed, and now I'm gonna name this.
Oh, right, okay.
So, propanyl methanoate.
You nailed it, Wayne. Congratulations.
I was just going for the opposite of what I thought.
Ah.
So you name this first, it's the alcohol first, but it's a nyl now, so it's bonded, it's not just propanol. Propanyl, then the methanoate, because it's a salt. So is it always alcohol first and carboxylic acid?
It is always alcohol first. That is a long word.
That's a big word for your Scrabble board. So is esterification.
That's a good word as well. I'm told, Wayne, I'm told. By Jimmy.
Jimmy.
There's another way to do it.
Oh, Jimmy is on it today.
He is doing well.
I'll teach you it though.
Alright,
because
okay.
I haven't done anything yet.
Oh, okay.
Just made
You turned the light off.
Well, that's just cheesy jokes though.
That is
do some chemistry now.
Alright, chemistry's better than cheesy jokes. Maybe.
Ish.
Ish.
Some doses. So, what we need is a special little anhydride. And
Oh.
for that to form, put yourself in this situation.
Okay. Anhydride. I need no water, Wayne.
You are going to need no water. So imagine you've got two identical molecules,
Right.
which I'm drawing up here. These are both methanoic acids. So as you very well shrewdly said there,
Yeah.
you've got to remove the water. So
Yeah.
you can remove the OH and the H, or you could remove the OH from here and the H here. Because they're symmetrical, doesn't matter which way.
That's alright then. Okay, with that.
So what's going to form is the C to O, down to this C, which has now lost this bond here, which is still going to be bonded to an O, that's still going to be bonded to that O, and the hydrogens are just chilling out here. And that's what's going to form when you take the water out of these two and push them together.
That's not an ester yet, Wayne.
It's not, this is just
Okay.
the first step.
Of many?
This is your acid anhydride. No, we're actually nearly there, we're nearly there.
Oh, alright, okay.
This is an acid anhydride. You react this with an alcohol, much like in yours, except it's
Okay.
an anhydride and an alcohol. So just give me a simple alcohol, please.
Okay, ethanol. That's quite simple.
Thank
You
you.
can make bad decisions with that. So I'm going to make a good decision and choose it.
It's a good decision.
Thank you.
So, we've got ethanol. So it's an
Yeah.
alcohol with an acid anhydride. That's the second way to make an ester.
Okay.
So what's going to happen is this bond here is going to break,
Right.
right? And one of these two bonds is going to break. Because it's symmetrical, it doesn't matter if it's this bond or this bond that breaks. Identical products will be formed.
The bottom one then.
The bottom one we're going to
Okay.
call this bond breaking. So it's the ones to the oxygens that are breaking, the single bonded oxygens that are breaking.
Okay.
So just for a second, what I like to do is picture all the products you've got at the second. So this, if you've got this C to 1 to O to H with no bond here because it's broken. You've got that one which is bonded to an O and that one O's not to anything. So you've got that, you've got those two things.
Right.
Then over here you've got the carbon to carbon with all these H's but not the OH.
Oh,
And
okay.
you've got the OH. And I like to look at it like that because now I can see what's going to happen.
Okay.
Because a logical thing to make here, because this carbon's got 3 bonds and it needs 4, that's a nice one to attach to it. It just makes a carboxylic acid, and that's
Quite a nice one.
that's quite a nice thing to make, I think. So
Okay.
that's one of your products, is you make a carboxylic acid, and that's linking those two things together,
Okay, which means then you must be linking those two things together at the end, Wayne.
which coincidentally makes an ester.
Ah, that is quite a nice coinkydink you got there.
Coinky dink, I got there indeed.
Yeah.
So it goes down to an O, but it bonds to this thing. So hang on a sec, hang on just a sec, hang on. There we go.
Oh, hang on, I got there. Okay, so that's your ester.
Yep.
So you started with methanoic acids, making a thing.
Yep, an acid anhydride.
Mixed it with that. So you got methanoic acid again, which is quite cool.
Yep, we can name that fine.
Alright, but this one.
This one's named in a similar way to before. Just because
Yeah.
it's an anhydride, you don't call the acid section of the ester anything weird. You
So you
always
still-
start with the alcohol.
Yeah, so we have ethyl, because it's 2,
Yeah.
and methanoate.
Methanoate. You don't change it because it was an acid anhydride. It's still in the ester form. It's just a methanoic acid section.
That's pretty swish, man, it's pretty swish. So that's always to form esters, isn't it?
Yeah. Now I've also heard rumours that if you have an ester
Yeah.
and you want to not have an ester so much, there's a way of doing that with water and hydrolysis. I've heard.
I heard that as well, it's the opposite of condensation, and I think I know one of the ways, Wayne.
Fantastic.
Alright, so I'll get on to explaining that. So, it's the opposite of condensation, so it just reverses it, essentially. So what I'm going to go through first is a reversible reaction. So I'm going to
So excited we are.
write massive excitement from the reversible reaction. So, we're going to need an ester. So would you like to suggest one, Wayne?
Yeah, you know what, I'm just going to draw the one that we've both formed both times.
Okay, so
It's just this simple methanoate section.
with the, well, I had a propanol,
You
but
did.
yeah.
Shall I go for my one?
Yeah, go
It's-
for
it's
refund,
short
it's shorter,
chain.
yeah.
So we've got that going on. They're
So
hydrogens.
what we add to this is we add some water.
So what you're going to do is you're going to force the water back into the bonds.
You are, and this is a reversible reaction, so the arrows are important.
Yeah.
And again, it needs a catalyst. Would you like to guess this one again, Wayne?
Yep. Well, I'm going to guess, quite simply, it's going to be an acid. I'm just going to go for it.
Yeah, that's good. Anyway, any more advances on the acid?
I'm going to go for sulfuric acid, but diluted now. Is that right?
It is right, Wayne. Well, congratulations.
Wow.
Now, you also do this under heat and under reflux, preventing any other things.
Extra things to know.
Yeah, so this is H2SO4, sorry. It could be hydrochloric acid, both work. And it's dilute, so I'm going to call it dill.
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 Yep, not short for Dylan, short for dilute.
Absolutely. So now we have this. It just breaks the bond, and the OH and the H go to where you'd expect them to.
Yep.
So
it's where they were
reverse.
before, right?
Well,
With the carboxylic
yeah.
acid. And
Yeah, the carboxylic acid has the OH. So this one, if you were to draw an intermediate, there'd be the hydrogen, and there'd be nothing here.
Yep.
And then there'd be the O and the C's here. But then this would go straight to the hydrogen. Do another arrow. Don't need one of those. Silly me. You have this with your OH.
So an OH from this goes to here.
Yeah, and then the O remains.
So just a H from the water goes to this one. So it's the same in reverse as what Triv's first thing was, when you remove the OH from here and an H from here. It's the same in reverse.
It is the same in reverse. Is there another way in?
There is, and this one's jazzy. You've got another word for your Scrabble board. Are you ready for this?
Oh, I am ready, I'm ready.
Saponification.
Saponification, that sounds a little bit like soap, right?
It does, and it's related for definite, Sonny Joe.
Ah.
So we have a nice ester. Shall we use the same ester?
I think we should. I found my lid.
Ah.
Anyone who was worried about where it was, it's okay.
I didn't even notice it was missing.
I did. Thank you. So we have our ester, okay.
Okay, this time rather than reacting it with water, we're going to react it with a hydroxide. I'm going to go with sodium hydroxide.
So is this still a hydrolysis, yeah?
It is a type of hydrolysis, yes.
Ah.
So what's going to happen is something's going to be forced in.
Okay.
So this doesn't break up in quite the way you'd think. You'd think it might break up into an Na plus and an OH minus, but it actually doesn't.
Doesn't it not?
It doesn't indeed.
Oh, D&E.
So what it essentially breaks up into is an NaO minus
Right.
and a H plus. Just like that.
Just like that.
Just like that.
Especially with the loose, that's important.
So if you look at this intermediate, Triv just drew it up, I'll draw it again. You've got this C, the one to O to H.
Oh,
not
so that's
bonded
the
to
same.
anything.
Okay, yeah.
And this one's still an O, C to C, just like that. That's this section here. So you've got those two things.
Okay, so would the same thing, sort of thing happen here, where that bit would go to there?
You're absolutely right.
Oh, excellent.
This still makes an alcohol, so that's the H part going on to the end. So
Okay, so you ended up with the same alcohol you did before.
yes, and that's one way to think about it. In this reaction you're going to end up with an alcohol, so this H has to go here, so the rest has to go here. It's the only tricky part is remembering that it's NaO minus rather than just Na plus, because that wouldn't make sense.
It wouldn't.
And you've got to keep it in ionic form, just worth a mention. It goes like this still. It bonds to the O, so it's O minus Na plus. Don't draw a line between them because it's not a covalent bond there.
Alright.
And now you know everything there is to know.
Everything?
Acids, or almost, but I think the next part we can teach them.
Yeah.
Uses of esters, very
Well,
briefly.
As we mentioned before, they smell sometimes.
So if you can get the right smell, it can be good for perfumes and stuff.
Which is a bonus.
If you want to smell like a goat or a leaf.
Or something, that's good. It's also used for food, flavourings and stuff, like apple and pear. Apple and pear. I love apple and pear.
I love apples and pears. And that's esters.
That is
I'm pro,
esters.
you're now pro, and if you're not, ask us pros questions.
Congratulations, you've passed.
Well done you.
Yeah.
You're now a clever cracker for the day. So that's everything about esters. We'll see you at the next video.
Alright, crackers and cheese, I think.
Absolutely.